the today's lecture, we discuss one of the important component also, that is the oscillator. That oscillator is used in many electronic gadgets, and it will be very beneficial for the electronic circuit. Basically, an oscillator is an electronic circuit that produces the repetitive electrical signal. Matlab means if we want to get the repetitive electrical signal in terms of the constant waveform of the frequency, we use the oscillator. So, we prepare the oscillator by preparing a small electronic circuit. We can say it is a very small electronic circuit, and that produces the repetitive electrical signal of a constant waveform and the frequency. And they are the fundamental building blocks of the modern electronics that used in wide variety of the devices and application. So, oscillators nowadays used in the many electronic devices, and it is having the very important applications. So, first we discuss what is an oscillator. Or what is an oscillator? Oscillator is a circuit that creates a continuous alternating waveform from a DC source without any external input. Means we are not giving any external input. By using the DC source, we are getting the alternating waveforms. Means now as it suggests that DC to AC conversion here. It converts a one-way current into an alternating waveforms at a frequency determined by its components. It means we can change the shape of the waveform as well as the frequency we can get by using the DC source. So, oscillator is a circuit that creates a continuous alternating waveform from the DC source, and here we not required any external input. So, the basic principle behind the working of the oscillator can be understood by analyzing the behavior of an LC tank circuit as you show in the figure. Now, which employs as the inductor, that is represented by the L, and the pre-charge capacitor, that is represented by the C, as its component we use in the LC tank circuit. So, here at the first the capacitor starts to discharge via the inductor. Means capacitor is going to be discharged as through the inductor, which result in the conversion of the electrical energy into the electromagnetic field, which can be stored in the inductor. So, once the capacitor discharge completely, there will be no current flow in the circuit. So, through the inductor, the capacitor starts to discharge as there is no current in the circuit. Because of this, capacitor discharges completely. Now, however, by then the stored electromagnetic field would have generated a back EMF, which result in the flow of the current through the circuit in the same direction as that of the before. This current flow through the circuit continues until the electromagnetic field collapses, when result in the back conversion of the electromagnetic energy into the electrical form, causing the cycle to repeat in this manner. However, now a capacitor would have charged with the opposite polarity, and due to which one gets an oscillating waveforms as the output. However, these oscillations cannot continue indefinitely due to the energy losses from the circuit resistance and causing their amplitude to steadily decrease, and until it fades completely. So, that result in the damped oscillation. So, when we talk about the flow of current flow through the circuit, first it is completely discharged and there is no flow of the current. As here what we are doing, we are just conversion of the electric energy into electromagnetic energy. When the stored electromagnetic field generated a back EMF, then the flow of current through the circuit in the same direction will happen, and this current flow through the circuit continuous until the electromagnetic field collapse, which result in the back conversion of the electromagnetic energy into the electrical form, and this cycle repeated. And in this manner the capacitor is charged with the opposite polarity, and due to the ones it gets oscillating waveforms as the output, and these oscillation cannot continue indefinitely due to the energy losses from the circuit resistance that causes the damped oscillations. So, this indicates that in order to obtain the oscillations which are continuous and of the constant amplitude, one needs to compensate for the energy losses. Nevertheless, it is noted that the energy supplied should be precisely controlled and must equal to that of the energy lost in order to obtain the oscillations with the constant amplitude. So, how it is happened? This is only because of if the energy supplied is more than the energy loss, then the amplitude of oscillation will increase, leading to a distorted output. While if the energy supplied is less than the energy lost, then the amplitude of oscillations will decrease, leading to unsustainable oscillations. So, we are having the two cases. In the one case, when the energy supply is more than that of the energy losses, then the amplitude of the oscillation will increase, leading to the distorted output. While if the energy supplied in number 2 case, while if the energy supplied is less than the energy lost, then the amplitude of the oscillation will decrease, and that lead to the unsustainable oscillation. You see on the screen here that here we are having an increasing oscillation, that is the case first. Now in the second, this is a decaying oscillations, this is a case 2, and this is a constant amplitude oscillation. So these are the 3 cases we can get as energy supply is more, the energy loss, the amplitude oscillation is increase more than that of the energy loss. So energy supply in this case in the first case energy supply is more, and the second case energy supply is less. Practically the oscillations are nothing but the amplifier circuit, which oscillations that in the amplifier circuit is because of the positive or regenerate feedback. So the oscillator are the amplifier circuits which are provided with a positive or negative feedback, wherein a part of the output signal is fed back to the input. Means we get the output signal, then this output signal again fed into the circuit as the input signal. So here the amplifier consists of an amplifying active element which can be transistor or an op amp. And you know the working of that transistor and op amp, that is an amplifier which consists of amplifying active material, and this transistor and op amp work as a amplifier in the circuit, and the back fed in phase signal is held responsible to keep up or sustain the oscillation. Because of this feedback, the oscillations are sustained in the circuit by making up the losses in the circuit. You see on the screen, this is the diagram, and here you see amplifier output we are getting, from the output we are giving the feedback, and this feedback again going into the amplifier, and this feedback is used for the circuit designing. So, this is the typical oscillator design. Now, once the power supply is switched on, the oscillation will be initiated in the system due to the electronic noise present in it. This noise travels around the loop, as we have seen in the last figure. This noise travels around the loop, gets amplified and converges to the single frequency sine wave. So, very quickly, so we are getting the sine wave as an output. So, the expression of the closed loop gain of the oscillator is as G is equal to A divided by 1 plus A beta. So, this is the gain which we get because of the travelling of the noise signal into the circuit. Now, where A, what is A is the voltage gain, and what is beta? Beta is the gain of the feedback network. So, A is the voltage gain of the amplifier, beta is the gain of the feedback networks. If A beta greater than 1, then the oscillations will increase in the amplitude. In the second case, if A beta less than 1, then the oscillation will be damped. When we increase the oscillation, then the A beta must be greater than 1. When we get the damped oscillation, then A beta less than 1. On the other hand, if we have the A beta is equal to 1, then we are having the constant amplitude. So, here we are having the 3 cases, and we have seen in the figure that here if A beta greater than 1, here we see that in this case A beta, in the figure A beta greater than 1, in the second case A beta less than 1, A beta is equal to 1, that represent the gain in the circuit. Now, if we take the now we have with 3 cases, A beta greater than 1, A beta less than 1 and A beta is equal to 1. In other words, this indicates that if the feedback loop gain is small, then the oscillation dies out. Means feedback plays a very important role in the oscillations, in the oscillator circuit also. If the gain of the feedback loop is large, then the output will be distorted. And only if the gain of the feedback is unity, then the oscillations will be of the constant amplitude, leading to the self-sustained oscillatory circuit. So, these are the 3 cases again on the basis of that A beta greater than 1, A beta less than 1, A beta is equal to 0. It means if the feedback gain is small, then the oscillation dies off. If the feedback gain is large, then the output will be distorted, and if it is constant, if it is gain feedback is unity, then the oscillation will be constant amplitude. What is the principle behind the oscillator? The oscillator converts the direct current from the power supply to the alternate current, and they are used in many of the electronic devices. The signals used in the oscillators are of the sine wave or the square wave, and that will give the output. For an oscillator to start and maintain its operation, the total loop gain of the system is very important. The product of the amplifier gain and the feedback loops gain must be equal to and greater than 1. So, it is very important when we maintain the operation of the oscillator. So, the product of the amplitude gain and the feedback loop gain must be equal or greater than 1. Additionally, if the phase shift around the loop must be sum of the multiple of 360 degree to ensure the signal reinforces itself with each cycle, leading to the sustained oscillation. So, this is the basic principle of the oscillators. The some of the examples are the signals are the broadcasted by the radio, television, transmitter, clocks, which are used in the computer and in the video games, like that. Now, another point is that what are the factors that affects the stability of the oscillator. So, we discuss one by one what are the factors that affecting the stability of the oscillator. The frequency stability is a very important factor for the oscillator, and it measures of the ability to maintain a constant frequency. That is, the frequency stability of an oscillator is a measure of its ability to maintain a constant frequency over a long time interval. However, it has been found if an oscillator is set at a particular frequency, it does not maintain it for a long period. So, frequency stability of an oscillator is a best measure. Now, next is the case of the cause of the change in the oscillation frequency or the factors affecting the stability of the oscillator given under number first point is the operating point. Operating point of the active device, like bipolar transistor is selected in such a way that its operation is in the non-linear region and changes the value of the device's parameter, which in turn affect the frequency stability of the oscillator. So, in oscillator the frequency plays a very important role, frequency stability. So, the frequency stability we use the operating point of the active devices, that is a bipolar transistor is selected in such a way that the operation is a non-linear region, changes the value of the device parameters that affects the frequency stability of the oscillator. Second is the circuit component, the value of the circuit component, that means we are using the resistors, inductors and the capacitor, change the variation in the temperature. Since such changes take place slowly, they also causes a drift in the oscillator frequency. Next is the supply voltage. The change in the DC supply voltage applied to the active devices shift the oscillator frequency also. So, this problem can be avoided by using the high regulated power supply. So, supply voltage is also the affecting parameter of the oscillator. Next is output load. Output load, a change in the output load may cause a change in the Q factor of the tank circuit. So, hereby it causing a change in the oscillator output frequency. Another parameter which affects the oscillator efficiency, that is the any change in the inter-element capacitances. It means inter-element capacitances are also the one of the parameter, and in the any change in the inter-element capacitances of the transistor, particularly collect to the emitter capacitance, cause the change in the oscillator frequency and thus affect the frequency stability. Next parameter is the stray capacitances. Stray capacitances also affect the frequent stability of the oscillator. Like the effect of the change in the inter-element capacitances can be neutralized by putting an additional capacitor across the corresponding element. So, however, it is difficult to avoid the effect of stray capacitances. These were the we have discussed that what are the parameter that affects the output of the oscillator, means it will affect the frequency of the oscillator. Now, in the next we discuss how many types of oscillators are. There are many types of oscillators, but can broadly be classified into the two main categories. First is the linear oscillators and second is the non-linear oscillators. In the linear oscillators, one term is the harmonic oscillator. In the non-linear oscillator, that is also the relaxation oscillator. In the harmonic oscillator, what is this harmonic oscillator? In the harmonic oscillator, the energy flow is always from the active component to the passive component, and the frequency of the oscillator is decided by the feedback path. This is a harmonic oscillator. Whereas in the relaxation oscillator, the energy is exchanged between the active and the passive components, and the frequency of oscillator is determined by the charging and discharging time constant involved in the process. So, these are the basically the two type of the oscillators, harmonic and relaxation oscillator. In the harmonic oscillator, it produces the low distorted sine wave outputs, while the relaxation oscillator generated the non-sinusoidal like sawtooth, like triangle or the square waveform we will get from this. So, we are having the two type of oscillator on the basis of the linear and non-linear oscillator. One is a linear oscillator, second is a non-linear. In the linear we have harmonic, in the non-linear we have relaxation oscillator. So, other types of oscillators are wind bridge oscillator, RC phase shift oscillator, Hartley oscillator, voltage control oscillator, Colpitt's oscillator, Clap oscillator. Others are also like crystal oscillators, Armstrong oscillator, tuned collector oscillator, gun oscillator, cross coupled oscillators, ring oscillators, dinatron oscillator, Misner oscillators. Another oscillators are also like optoelectronic oscillator, precise oscillator, next is Robinson oscillator, treated oscillators, Pearson Anson oscillator, delay line oscillator, Royer oscillators, electron coupled oscillators, multi-wave oscillators, and these oscillators have respective its applications in the many electronic gadgets. So, on the basis of construction's principle, these oscillators are used in the many electronic devices. So, we will discuss few of them in the further lecture regarding this oscillators types. So, we will discuss how they are constructed, how they are operated, what are their application, that we will discuss in the further lectures. Oscillators can also be classified into the various types depending on the parameter consideration, that based on the feedback mechanism, the shape of the output waveform, and on the basis of that the oscillators are classified. That will be discussed in the further lecture. Thank you very much.